Hello everyone, today we are going to see the generating function for Pnx. When the function 1 by square root of 1 minus 2xz plus z square is expanded, we are getting Pnx as the coefficient of z raised to n. Hence the function 1 by 1 minus 2xz plus z square is called as the generating function for Pnx. So we can write 1 by square root of 1 minus 2xz plus z square is equal to sigma n is equal to 0 to infinity Pnx into z raised to n. So in order to derive the proof for this generating function, we are using this formula. 1 minus 5 raised to minus 1 by 2 is equal to 1 plus 1 by 2 y plus 1 into 3 by 2 into 4 y square plus etc. 1 into 3 into 5 etc. 2n minus 1 divided by 2, 4, 6 etc. 2n into y raised to n. So while going to the proof, we can write the function 1 by square root of 1 minus 2xz plus z square as 1 by square root of 1 minus, taking minus z outside, minus z into 2x minus z is equal to 1 minus z into 2x minus z the whole raised to minus 1 by 2. This is of the form 1 minus y whole raised to minus 1 by 2, which can be written in this form. So it is written as 1 plus 1 by 2 into z into 2x minus z plus 1 into 3 divided by 2 into 4 z square into 2x minus z the whole square plus etc. 1 into 3 into etc. 2n minus 3 divided by 2 into 4 etc. 2n minus 2 into z raised to n minus 1 2x minus z raised to n minus 1 plus 1 into 3 into etc. 2n minus 1 divided by 2 into 4 etc. 2n into z raised to n into 2x minus z the whole raised to n plus etc. Now we need to expand all these 2x minus z raised to n, 2x minus z the whole raised to n minus 1 etc. Then only we will get the coefficient of z raised to n from each term of this expression. For that we are using the relation a minus b the whole raised to m is equal to a raised to m minus mc1 a raised to m minus 1 b plus mc2 a raised to m minus 2 into b square minus etc. Alternate terms are negative and positive. Okay, so 2x minus z raised to n is equal to 2x raised to n minus nc1 2x raised to n minus 1 z plus nc2 2x raised to n minus 2 z square minus etc. Now what we need is z raised to n into 2x minus z the whole raised to n. 2x minus z the whole raised to n is already written here. Now we need to multiply it with z raised to n. So z raised to n into 2x minus z the whole raised to n is equal to 2x raised to n into z raised to n minus nc1 into 2x raised to n minus 1 into z raised to n minus 1 plus nc2 into 2x raised to n minus 2 into z raised to n plus 2 minus etc. Now here the term containing z raised to n is this term. All other terms will be higher powers of terms higher than z raised to n. So we need to consider only this term. Okay. So the coefficient of z raised to n in the expansion of z raised to n into 2x minus z the whole raised to n is 2x the whole raised to n. Okay, so from this term we are getting the coefficient of z raised to n as 2x the whole raised to n. So we can write the coefficient of z raised to n in the n plus 1th term, that is this term. Okay, of the expansion is considering all the other terms here 1 into 3 into etc. 2n minus 1 divided by 2 into 4 into etc. 2n, and from here we are getting the coefficient of z raised to n as 2x the whole raised to n. That is written here. So this is the coefficient of z raised to n from the n plus 1th term. Similarly, we need to consider the coefficient of x raised to n from the nth term, n minus 1 term, etc. So, in order to get the coefficient of z raised to n from the nth term, we need to consider z raised to n minus 1 into 2x minus z the whole raised to n minus 1. So, first we will expand 2x minus z the whole raised to n minus 1. Then we will multiply with z raised to n minus 1, and from there we will take the coefficient of z raised to n. So first we are going to expand 2x minus z the whole raised to n minus 1, which is 2x raised to n minus 1 minus n minus 1 c1 into 2x raised to n minus 2 z plus n minus 1 c2 2x raised to n minus 3 into z square, etc. Okay. Now, multiplying with z raised to n minus 1, this equation we will be getting 2x raised to n minus 1 into z raised to n minus 1 minus n minus 1 c1 2x raised to n minus 2 z into z raised to n minus 1. Okay, here already one z is there, that z into z raised to n minus 1, which is z raised to n, plus n minus 1 into n minus 1 c2 2x raised to n minus 3 z square into z raised to n minus 1, which is z raised to n plus 1 minus etc. So here the term containing z raised to n is this term. Okay, so we need to consider only this term. So in this expression, the coefficient of z raised to n is minus n minus 1 c1 2x raised to n minus 2. And since we are considering the nth term, we need to consider the coefficient of z raised to n here. So the coefficient of z raised to n in the nth term of the expansion is 1 into 3 into etc. to n minus 3 divided by 2 into 4 into etc. to n minus 2 into z raised to n minus 1 2x minus z raised to n minus 1 into minus n minus 1 c1 2x raised to n minus 2. That is written here. So now we understood the fashion in which it is coming, isn't it? First term is 1 into 2 into etc. to n minus 1 divided by 2 into 4 into etc. to n into 2x raised to n. Next one is 1 into 3 into etc. to n minus 3, 2 into 4 into etc. to n minus 2. So for the n minus 1 term, this term will be 1 into 3 into etc. to n minus 5 divided by 2 into 4 into etc. to n minus 4. Then the third term will be positive, and this will be n minus 2 c 2 2x raised to n minus 4. So that is written here. Okay, so now we can collect all these terms and write the coefficient of z raised to n in the expansion of 1 by square root of 1 minus 2xz plus z square, which is the first coefficient, okay, which we obtain from the n plus 1th term. The coefficient which we, or the second one is the coefficient which we obtain from the nth term. Third one is the coefficient which we obtain from the n minus 1th term, etc. So that is 1 into 3 into 5 etc. to n minus 1 divided by 2 into 4 into 6 etc. to n into 2x raised to n minus 1 into 3 into 5 etc. to n minus 3 divided by 2 into 4 into 6 etc. to n minus 2 n minus 1 c1 into 2x raised to n minus 2 plus 1 into 3 into etc. to n minus 5 divided by 2 into 4 into etc. to n minus 4 into n minus 2 C2 into 2x raised to n minus 4 minus etc. Now, first term we are writing like that itself. In the second term, we are multiplying by 2n divided by 2n minus 1 and dividing by 2n by 2n minus 1, which will appear as this term into 2n minus 1 by 2n. Okay. So, in the second term, we are multiplying and dividing by 2n by 2n minus 1. In the third term, that is this term, we are multiplying and dividing by 2n into 2n minus 1 into 2n minus 3 divided by 2n minus 2. Okay, multiplying and dividing by 2n into 2n minus 1 into 2n minus 3 divided by 2n minus 2. So that is the change we made while coming from this equation to this equation. Okay. Now, in the next equation, we are just arranging it. That is, in the second term can be written as 1 into 3 into 5 etc. 2n minus 3 into 2n minus 1 into 2n divided by, this is 2 into 4 into 6 etc. 2n minus 2 into 2n. Okay, so that is written here. First term is the same. Second term is 1 into 3 into 5 etc. 2n minus 3 into 2n minus 1 divided by 2, 4, 6 etc. 2n minus 2 into 2n. What is remaining here is 2n, that is written here, and what is remaining here is 2n minus 1, that is written here, and all other terms are written here. And in the third term also we are arranging like that. That is 1 into 3 into 5 etc. 2n minus 5 into 2n minus 3 into 2n minus 1 divided by 2 into 4 into 6 into etc. 2n minus 4 into 2n minus 2 into 2n. Okay, and writing the remaining terms, that is 1 into 3 into 5 etc. 2n minus 5 into 2n minus 3 into 2n minus 1 divided by 2 into 4 into 6 etc. 2n minus 4 into 2n minus 2 into 2n. What is remaining here is 2n minus 2 into 2n, that is written here, and what is remaining here is 2n minus 1 into 2n minus 3, that is written here, and the remaining terms are written here. So now we can take 1 into 3 into 5 into etc. 2n minus 1 divided by 2 into 4 into 6 into etc. 2n common from all these terms. Okay, so that is taken common and written. So that is 1 into 3 into 5 etc. 2n minus 1 divided by 2 into 4 into 6 etc. 2n. What is remaining in the first term is 2x raised to n minus 2n by 2n minus 1 into n minus 1 c1 into 2x the whole raised to n minus 2 plus 2n minus 2 into 2n divided by 2n minus 1 into 2n minus 3 into n minus 2 c2 into 2x raised to n minus 4 minus etc. Now this 2 into 4 into 6 into etc. 2n can be written as 2, can be written as 2 into 1, 4 can be written as 2 into 2, 6 can be written as 2 into 3 etc. 2n can be written as 2 into n. Taking all these 2 together, we will be getting 2 raised to n, which is written here, and what is remaining here is 1 into 2 into 3 into etc. n, which is n factorial, and that is written here. So this term can be written as 1 into 3 into 5 etc. to n minus 1 divided by 2 raised to n into n factorial, and all other terms are the same, no changes made, so I am not repeating that. Okay, so now here in the next step, the third step here, we are going to write this as 2 raised to n into x raised to n. So this is 2 raised to n into x raised to n. 2x the whole raised to n is 2 raised to n into x raised to n. And here it is 2 raised to n minus 2 into x raised to n minus 2. Here it is 2 raised to n minus 4 into x raised to n minus 4. That is the only change made when we come from this step to this step. Okay. Now we need to find out what is n minus okay, and not only that, we are finding out what is n minus 1 c1. Okay, what is n minus 1 c1? N minus 1 c1, you know that mcr is m factorial divided by r factorial into m minus r factorial. So that n minus 1 c1 is equal to n minus 1 factorial divided by n minus 2 factorial into 1 factorial. 1 factorial is 1, while writing n minus 1 factorial and n minus 2 factorial, here in the denominator you are having all terms up to n minus 2, and in the numerator we are having all terms up to n minus 1. So so the terms up to n minus 2 get cancelled from numerator and denominator, and what is remaining here is n minus 1. Okay, n minus 1 factorial is 1 into 2 into etc. n minus 2 into n minus 1, and n minus 2 factorial is 1 into 2 into 3 etc. n minus 3 into n minus 2. So from the numerator and denominator, all terms up to n minus 2 will get cancelled, and what is remaining is n minus 1, that is written here. So instead of n minus 1 c1, you can write n minus 1. Similarly, we have to find what is n minus 2 into c2. N minus 2 into c2 is n minus 2 factorial divided by n minus 4 factorial into 2 factorial. 2 factorial is 2. N minus 2 factorial is 1 into 2 into 3 etc. N minus 4 into n minus 3 into n minus 2, and n minus 4 factorial is 1 into 2 into 3 etc. n minus 5 into n minus 4. So from the numerator and denominator, all terms up to n minus 4 get cancelled, and what is remaining is n minus 3 into n minus 2. That is written here, n minus 3 into n minus 2, and divided by 2 factorial, which is 2. So in the place of n minus 2 into c2, we are going to substitute this. Okay, so we are writing here n minus 3 into n minus 2 divided by 2. Okay, so and from this equation we can take a 2 raised to n outside. Okay, from the first equation, when we are taking 2 raised to n outside, what is remaining is x raised to n. That is written here, x raised to n, and here we are having 2 raised to n minus 2 into 2, which is 2 raised to n minus 1. If we need to take 2 raised to n outside, we need to multiply and divide by 2. Then the numerator will become 2 raised to n, and in the denominator a 2 will be appearing. So that is written here. So what will be remaining here is n into n minus 1 into x raised to n minus 2 divided by 2 into 2 raised to n minus 1. That is written here. From this equation also, we are taking 2 raised to n outside. Here we are having 2 raised to n minus 4 into 2 square, which is 2 raised to n minus 2. If we need to take 2 raised to n outside, we need to multiply by 2 square in the numerator and 2 square in the denominator. So the numerator will become 2 raised to n, and in the denominator a 4 will be appearing. So from the numerator we are taking this 2 raised to n outside, and in the denominator you will be having a 4, that is written here. So this term will become after taking 2 raised to n outside, n into n minus 1 into n minus 2 into n minus 3 divided by 2 into 4 into 2n minus 1 into 2n minus 3 into x raised to n minus 4. So while doing all this manipulation, the resulting equation is 1 into 3 into 5 etc. 2 raised to n minus 1 into 2 raised to n and divided by 2 raised to n into n factorial. This 2 raised to n and 2 raised to n get cancelled, and we are having 1 into 3 into 5 etc. to n minus 1 divided by n factorial into x raised to n minus n into n minus 1 divided by 2 into 2n minus 1 into x raised to n minus 2 plus n into n minus 1 into n minus 2 divided into n minus 3 divided by 2 into 4 into 2n minus 1 into 2n minus 3 into x raised to n minus 4 minus etc., which is Pnx. So we are getting Pnx as the expansion of the function 1 by as the coefficient of z raised to n in the expansion of the function 1 by square root of 1 minus 2xz plus z square. That is why that function is known as the generating function for Pnx. Okay. So this can be written as 1 by square root of 1 minus 2xz plus z square is equal to sigma n is equal to 0 to infinity Pnx into z raised to n, which can be expanded as p0x plus p1x into z plus p2x into z square plus etc. Now we need to show that Pn of 1 is equal to 1. For that we are writing the generating function 1 minus 2xz plus z square the whole raised to minus 1 by 2 is equal to sigma n is equal to 0 to infinity Pnx into z raised to n. Now we are going to put x is equal to 1. Then the LHS will become, when x is equal to 1, LHS is 1 minus 2z plus z square the whole raised to minus 1 by 2, which is 1 minus z the whole square raised to minus 1 by 2, which is 1 minus z the whole raised to minus 1, which can be written as 1 plus z square plus etc. z raised to n plus etc. So, and when x is equal to 1, RHS of equation will become sigma n is equal to 0 to infinity Pn of 1 into z raised to n, which can be written as p01 plus p1 of 1 into z plus p2 of 1 into z square plus etc. plus Pn of 1 into z raised to n plus etc. So now we can equate the coefficient of z raised to n from equation 2 and 3. So we'll be getting 1 is equal to here. The coefficient of z raised to n is 1. So we can write 1 is equal to, here the coefficient of z raised to n is Pn1, or we are getting Pn of 1 is equal to 1. Next one is to show Pn of minus x is equal to minus 1 raised to n Pn of x. Here also we are using the generating function for Pnx, which is 1 by square root of 1 minus 2xz plus z square is equal to sigma n is equal to 0 to infinity Pnx into z raised to n. When x is equal to minus x, this equation number 1 can be written as, when x is equal to minus x, this will become 1 plus 2x z plus z square. So that is written here, 1 square root of 1 by square root of 1 plus 2xz plus z square. Here instead of x we need to write minus x. So RHS will now become sigma n is equal to 0 to infinity Pn of minus x into z raised to n. So expanding, we can write, expanding RHS we can write P0 raised to P0 of minus x plus P1 of minus xz plus P2 of minus xz square plus etc. plus Pn of minus x z raised to n plus etc. and name it as equation number 2. Again, when x is z is equal to minus z, equation number 1 becomes, that is, when x is equal to minus z, this equation will become square root of 1 by square root of 1 plus 2xz plus z square sigma n is equal to 0 to infinity Pn of x into minus z whole raised to n Expanding, we can write P0x plus P1x into minus z plus P2x into minus z square plus etc. Pnx into minus z raised to n plus etc. Okay, now here minus z can be written as minus 1 raised to 1 into z. Minus z square can be written as minus 1 square into z square, and minus z raised to n can be written as minus 1 raised to n into z raised to n. Now we can see that LHS of equation number 2 and equation number 3 are the same. So we can equate the coefficient of z raised to n on the RHS. So combining the coefficient of z raised to n on both sides of equation 2 and 3, we will be getting the coefficient of z raised to n here is Pnx into minus 1 raised to n, and the coefficient of z raised to n in this equation is Pn of minus x. So we can write Pn of minus x is equal to Pnx of minus 1 raised to n, or Pn of minus x is equal to minus 1 raised to n Pn of x. Hence that relation is proved. Thank you.